Hello, everybody. Hello. People are joining. I see the attendee count growing. Welcome, welcome. Good morning, good evening, good afternoon, good night, wherever you are in the world. I'm going to give a minute or so for everybody to jump in from the waiting room. Keep them coming. This is runZero, our webcast episode 10, or episode OXOA, which is that's the new line episode, right? So if we want to get the carriage return, we've got to wait until December. That's my little geeky one there. So welcome everybody to the runZero Hour. Today I am joined by Tom Sellers, who is a principal researcher here at runZero, Blaine Smith, who is a senior researcher here at runZero, and Tyler Diderich. And Tyler, what's your title at runZero?
Yeah, so I'm on the customer success engineering team, official title being manager of customer success engineering. So long-time listener, first-time caller here for runZero Hour. So excited to be here.
We are very, very happy to have you. Thank you for joining us today. So, and also I want to point out, I'm not doing my usual geeky t-shirt this time. I actually have gone from geek to chic, and I'm wearing the runZero polo. It's very stylish. So, but next month I've got a t-shirt in the wings just for y'all. So without further ado, let's get started. What are we going to discuss today? So today we're going to take runZero's unique perspective into IT environments and discover how the remote desktop protocol has evolved with Windows. As Windows has evolved, such has RDP, and see how it's become more secure by default. And it's really interesting how runZero can peer into that. And Tom's going to take us through that. It's going to be fascinating. And then Blaine is going to take us through the ATG and PC-WORX OT protocols, along with a bit of a deep dive into their security architecture. And you know me, I love a good OT protocol, so that's going to be super exciting. Then we're going to talk about the world of active discovery in OT environments with a bit of a digression into the report recently released by the National Renewable Energy Laboratories SECA group. And then Tyler's going to talk about the runZero platform API and how the use of that API and how customers have used that API have actually driven new features in the runZero product. And then we're going to dive into the vulnerability landscape with all of the rapid responses from the last month. And boy, howdy, there were a lot of rapid responses. So we're not even going to get to cover all of them, but that's going to be exciting too. So without further ado, let me hand the mic virtually over to Tom, who's going to discuss the evolution of RDP security and the impact of defaults. So, Tom.
Hey, folks. As Rob pointed out, I wanted to talk about RDP, how it's evolved over the years in response to threats, and how we can measure how certain security features have been implemented and what the impact is in production environments today, like the real world impact of certain choices that Microsoft has made. Mm-hmm. So before I sort of dig into things, I want to sort of provide some context. Some of this is going to be explanations of what things are, and some of it's going to be history that will become a little more relevant here in a bit. So first off, what are remote desktop services? So remote desktop services are a set of features from Microsoft to allow a person to remotely connect to a Windows host and basically get a desktop. And the use for that can be anything from an administrator remotely administering a single server to give them the ability to manage a host that's in a data center, or it's in another state, it's somewhere else. And then the other end of the gamut is folks who have set up entire virtual desktop infrastructures where they have just a ton of desktops that people RDP into, that end users RDP into, and they can do things like print and run applications. And the benefit of that is it gives the administrators the ability to have much more control of their environment, constrain it, provide consistent experience for folks, do things like manage bandwidth consumption, and improve security somewhat. So remote desktop service is just basically a service within Windows that enables a remote presence to effectively a virtual desktop. And On the history side of things, this got started back in 95 somewhat when Citrix released a product called WinFrame. And essentially it did the original bare bones version of this on Windows. What they did was they licensed Windows NT 3.51 and they put their secret sauce on top of it, and it provided remote desktops for users. It wasn't as fully featured as you would see today, but it did provide remote functionality for end users. And that was successful enough that Microsoft, in a couple of years, licensed portions of that functionality from Citrix and created their own product that they released as part of Windows NT 4.0. And it was its own dedicated SKU. It's called Windows NT 4 terminal server, terminal services rather. And it was something that you would run as a dedicated server. It wasn't like built into every version of Windows. And that apparently was successful enough that starting with Windows 2000, Microsoft just baked it into Windows as a component. Much like IIS today, certain other services, whenever you installed Windows, you could just go in and check the option and install the terminal services feature and then configure it independently. More functionality for managing and providing access was layered on later, but with every successive version of Windows, there were versions of, well, pretty much every version of Windows, there were improvements to the remote desktop services, which is what terminal services will be called later, with adding functionalities like dedicated apps and better printing, clipboards, playing sound. Like, it just evolved over time to provide more and more features that customers wanted. So that's sort of like what our remote desktop services is and sort of how it got its start. And so what I want to talk about next is some of the risks and threats that related to remote desktop services early on that sort of spurred improvements to the security posture and security features of remote desktop services. So in the beginning, so to speak, there was one authentication protocol that we today call legacy RDP authentication protocol or standard RDP authentication. And it had a variety of risks related to it. And so the first one that I want to talk about is that it was susceptible to man-in-the-middle attacks for a couple of reasons. And some of those are, sort of understandable today, and some of them are sort of like you shake your head. So whenever Microsoft implemented the remote desktop authentication, like the original legacy authentication mechanism, what they did was they took and encrypted the session communications with a symmetric cipher, which is pretty standard. And then they did what we do in TLS today, which was they solved the problem of trying to get that symmetric cipher's cryptographic key between the client and the server by using public key encryption or asymmetric encryption. Today, we would do that with RSA if we're just going to share a key. But in their case, they did use RSA certificates, but they did it in sort of a broken way. So to sort of explain why it's important, let me back up a little bit. Whenever you implement symmetric encryption, both sides of the conversation use the same cryptographic key in order to encrypt and decrypt. And so anybody with that key can decrypt the traffic. And the challenge whenever you're negotiating those type of communications is how do you either share or agree upon the key that you use to do decryption. What Microsoft decided to do here was they implemented a cipher suite, a cipher called RC4, which is a stream cipher for the symmetric key encryption. And then to do the key portions, the secrets that would be used for this, what they decided to do was they would have the server create a random value and then share that with the client on the wire in the clear. And then they would also share a certificate. And the intent was that the client would then generate its own part of a secret and then use that public key certificate to encrypt it and send it back to the server. And with public-private encryption or asymmetric encryption like that, typically only the person, if you encrypt it with the public portion, only the person with the private portion can decrypt it. So the intent was now the server has the client secret and the server secret, and the client has both parts of secrets as well. And then they use that to compute what is used as the cryptographic key across both of them. Great, cool. In theory, other than the weak ciphers that are being used, that's not too different than what we do with TLS today. Although it's on a decline, that's sort of the standard. Unfortunately, what Microsoft did was the public key that was used, the public private key that was used was baked into Windows. They used the same key for every Windows installation. So you could stand up a box, install it from scratch, and you're going to have the same key as somebody else on the other side of the planet who did the same thing. What that means is that attackers can then extract the key from the operating system. And once they do that, they now have the private public key pair. And if they get their hands on packets like a capture of the communications, they can now decrypt the encrypted client secret. They already have the server secret because it's sent in the clear, put those together, do the same math that both sides do, and they can decrypt the entire conversation. That includes authentication and includes everything sent over RDP. And that's a lot because like RDP, when you have a desktop and a server and you're communicating back and forth, like you're sending screen paints down so you can draw what's on the screen, the client sending keystrokes and mouse commands and clipboard contents and printer contents and audio, like all this is going back and forth. And you can now decrypt that from the packets. So, well, that's bad. And that secret is that particular key you can still get today, not because you can just go extract it from a Windows 2000 box. You can go to Microsoft's TechNet articles and download a copy of the bits. Like they've just gone ahead and shared it. It's so compromised at this point. So that's not great. That's one part of it. The stream cipher that they used was RC4. Today, we consider that incredibly broken. It was common then, used it in web and WPA and TLS, but today we know it's incredibly broken. It's so broken that in 2015, an RFC was opened to request the prohibition of using that with TLS at all, using RC4. And that was way past time then. So that was weak. And then the last sort of part that sort of enabled man-in-the-middle active attacks and passive, packet capture attacks was it supported relatively weak key sizes. So at the time when this was going on, we had this thing in the States where there was export bans on cryptographic algorithms with certain key sizes. So like your export version of certain things, like a lot of people would run into this back in the day with Internet Explorer, you'd have the 40-bit version. Well, this supported 40-bit keys. It supported 56-bit and 128-bit too, but it also supported small ones. And those are easy. Those were factorable within 5 years of like common usage of this anyway, but like they're definitely factorable now. So all this means that if someone is in a privileged position on the network to either capture the traffic or actively interfere with it, like they can actually interdict the server's response with their own certificate in there and proxy comms back and forth and inject keystrokes, that made this susceptible to man-in-the-middle attacks through a couple of different mechanisms. The next threat is brute force. There's no built-in mechanism within RDP or in Windows generally that would have prevented people from using tools like Hydra and Encrack from trying username and password combinations against RDP with the intent to try to find valid credentials. You could just sit there and spam them. Now, there are controls in Windows that you can use that will allow you to disable or automatically lock out accounts after a certain number of logins. There's some controls like that, but typically those aren't on by default. Logging for failed logins isn't generally on by default, particularly in earlier versions of Windows. So your administrators have no idea that this is going on. That's one of my biggest complaints about Windows audit logs is you have to turn on so much just to get useful data, particularly in the early days. And then administrators will often not apply the lockout policies to admin accounts because if it's a remote server, you don't want to be ever prevented from getting in due to failed passwords. And so that meant attackers just sit there and abuse their targets. They could spin up multiple connections and just have Encrack or Hydra just throwing these things at it until they get to it. And if you think about, back in those times, the typical password length and the care that people put into those, it just wasn't good. That leads me to the next thing, which is denial of service. So it turns out that when you use legacy RDP auth, before you authenticate, like when you connect, before you authenticate, the server spins up the resources necessary to provide you a desktop. Like it's allocating memory, it's allocating all the resources necessary to paint that desktop, to draw it, to provide you the service you would expect. They spin all that up, then you authenticate. Well, attackers can just open a ton of connections, which all require provisioning the memory and resources necessary for that desktop, and they can starve the server of memory and cause it to crash. So you can either deny people from getting in if there are limitations on the number of connections, or they can just straight up cause the server to crash if the server didn't have a lot of memory and the network connection was fast enough. And you could accidentally do that if you're brute forcing credentials, because every time they connect to try a credential, you're getting a full desktop allocated. So that's not great. And the final one here is information disclosure. And so, as I mentioned, when you connected, it would provision sort of an environment for the person who connected before they authenticated. Rob, if you go to the next slide for me. And what this would look like is the same thing you would see as if you were sitting at the console and you hit, you just viewed the console. So when you connect, you'd see in some cases the accounts of users who had previously authenticated. And if you're an attacker, that now gives you valid accounts that you can use to target in your cracking attempts. Like in this case, you can see priv user and user 01 or whatever. That makes it so much easier to try to find a valid account, because you now have part of the combination. You now have the username, and you're pretty certain this person can log on to this box. It's not like a service account or something like that that doesn't have interactive login privileges. And if you click on one of the users, you can often see the name of the server. So, and if you look at the bottom of the screenshot, you can see the version of the server. So that gives you, the attacker, a lot of information, not just about this particular host and the users in the environment, but like the environment together, like what versions of Windows you run, things like that. And so all of these risks started becoming more and more of an issue, because in the late 90s and the early 2000s, more and more people were putting things on the internet. Usually things they shouldn't, but putting things on the internet, and they're having more bandwidth to do this. Data centers are starting to deploy Windows more and more and deploy hosted apps and things like this. And so these risks are now exposed to more attackers, and these are juicy targets. You get remote desktop on a box, you can then use that leverage to attack further onwards inwards. You can access whatever the user can access, obviously, of what the box you compromise, but then you can start exploring the network. And that's still a problem today. It still happens today. Organizations still get popped through RDP on the internet, but this had other risks that we don't necessarily have today. And it was becoming more and more prevalent, again, because people were putting more things on the internet. And in a lot of cases, admins didn't understand how weak the security was. They didn't think about the sort of the blast radius of a compromise in an RDP host. Security wasn't as much in the forefront of thinking for administrators as it may be today. And so this was just becoming more and more of an issue. Next slide, please. So those are like the sort of the core issues that were relevant to the early RDP implementations. And what I want to talk about now is sort of how Windows has evolved and the RDP protocol has changed to provide better security. And as I said earlier, like remote desktop, or pretty much every version of Windows has improved remote desktop in some way. And it's not always in security, it's in features and things like that, but security has come along for the ride. And over the years, they've added more and more security related features to improve outcomes here. So Windows 2000 is the first time it was sort of built in as a component in every version of Windows. Admins could use it. You could set up application farms. You could set up hosted applications, things like that. Enterprises were adopting it. And then in 2003, Microsoft added a new feature for authentication. It allowed folks to protect their communications with TLS. And so instead of RC4 and its key exchange, what you could do is you could enable TLS, and it would use standard TLS to protect the communications. And that has a ton of benefits. All the things that come along for the ride with TLS are incredibly useful in this case. And so instead of being stuck with RC4 as your symmetric crypto, you can literally use any valid symmetric crypto that TLS supports. Whenever 2003 Service Pack 2 got AES, your RDP automatically got the ability to use AES encryption instead of trip DES or something like that. When you get better key exchange protocols like elliptic curve or Diffie-Hellman, you automatically get to be able to use those so long as your client and your server both support those. And so the benefit of this is, one of the benefits of TLS is that you have a lot more options, for a lot more secure options for communicating, and you're not just fixed to one. Another benefit is that TLS on Windows, it's not often done, but it can be very, very finely tuned. You can turn off cipher suites, you can turn off hashing mechanisms, you can turn off symmetric, like if you're If you've got a regulator that says you can't use this crypto or you must use this other crypto, if you have operational issues, you can turn off and tweak all various settings in TLS to get it tuned to exactly what you need. And that extends to RDP as well. So you have a ton more control. And as new things get introduced, like today, whenever TLS 1.3 was added to Windows, RDP automatically uses it because it uses TLS. So you just get to take advantage of all the improvements. And so that the introduction of TLS allowed the mitigation of pretty much all the man-in-the-middle risks, because you had a lot better crypto, you had a lot more modern crypto, you had a lot more control over it. And another benefit is that with TLS, you have the opportunity, not a lot of people took advantage of it, but you did have the opportunity to use to configure the certificate that is on your RDP server. So if you have PKI, public key infrastructure or PKI in your organization, you could generate and assign certs to your servers, and they could be provided to the client. So you now can identify the server on the other end, which with legacy RDP, you couldn't do that. You just connected, hoped it was your guy. But with certificates, you could identify and verify that identity. And so that's a lot, that's another way that it helped enable mitigation of man in the middle. So that's Windows 2003. That was a great benefit. Along comes Windows 2008, and Windows 2008 implements my favorite feature in this whole thing, network level authentication. Basically what network level authentication is, or NLA, is Microsoft has implemented this as a mechanism for doing a couple things. One, it requires authentication before a session's built. So before you get a desktop, before you see anything on the other side, before resources are allocated, you have to authenticate. Right. That mitigates some of the information disclosure. It mitigates the denial of service. At the time, and at least for many years, it mitigated brute force attacks because Hydra and Encrack didn't support NLA at all. They just fell over. That's assuming that you could only do NLA. We'll get into that in a second. So that's great. The other thing it did, in addition to requiring authentication up front through a couple different mechanisms that are standard Windows authentication mechanisms, the other thing it did is it required TLS. You could no longer use the legacy encryption. You had to have TLS first in addition to that. So it sort of forced a companion control that was already good. NLA, as I said, mitigated pretty much the most of the rest of the issues, and it had a real meaningful impact. The only downside of this was that by default, NLA is enabled, but also TLS or the way it's called, excuse me, the way that TLS is called in UI is SSL. It means TLS to the latest version, but they called it SSL at the time. And it also supported legacy RDP. So you still had all the old stuff. The attack still worked against those, but you had the ability to use NLA and to configure the host to only support NLA. It was optional. But it was now a tool in your toolkit to shut down some of these risks. Next slide, please. And then along comes 2012, Windows Server 2012. And NLA is required by default, because the checkbox that says only support connections by clients with NLA is set. And that is amazing because it means all the default risk related to the legacy protocols is gone. You have to take take intentional action to unflip this box. And as a former admin, I can tell you, we're lazy. We don't turn nerd knobs. We don't flip bits unless we have to, because we have so much else going on. We have other fires to deal with. So that means that unless you have a compelling reason, you generally don't flip this back. It's the default. It's great. I love this. I wish more things were secure by default. So when I talked about admins flipping these bits, there's a couple reasons why you might. One is compatibility challenges. There may be portions of an organization in which they have legacy clients. They have old Windows, say, early XP or Windows 2000 boxes that don't support NLA. They may have some thin client, like something from Wise or whatever, that doesn't support the protocol. And so for compatibility reasons, they don't turn this on. I have managed such environments with clients, with third-party clients that had these requirements. It makes me sad. I literally today saw a blog post from 2023 where somebody wanted to force disable this on their domain controllers. That makes me really sad. So compatibility issues are one reason why you might flip that back to not requiring NLA. The second one is a minor issue, in my opinion, with password changes. And that issue is with legacy RDP, when you authenticate to your server, you get the full desktop experience as if you're sitting there. And you can, send a control delete, and you can put in your credentials. And if your password is expired, you get prompted to change your password. Like, you've already authenticated. Now they know who you are. Your password is expired. I need you to put a new one in. With NLA, that doesn't happen. You don't have that interactive ability. And so if your password is expired, you just fail to log in. And for certain configurations, like a remote host in the state, that could be problematic. But for enterprise environments, there's workarounds. Like, you go to another machine and authenticate, change your password, go about your business if you're in Active Directory. There is tooling that comes along with remote desktop that you can install called Remote Desktop Gateway. It's basically a web app that you log in with a form, and it allows you to then go on to another box to remote desktop in. It's sort of like a proxy. It's a gateway. And that can be configured to allow you to change your password. It's an optional setting. You have to go in and flip some bits, but it's doable. And so that gives you a workaround for it. But that's like the major reasons why you would change those. The unfortunate side effect is that environments that maybe had compatibility issues early on would set those bits or set a group policy that flips the bits, and then later wouldn't revisit that. And so you would just have this policy that goes on and on until it gets challenged, until an auditor comes in or somebody sees it, has a question. So it may be in place well past when it's required, or it may be in place on boxes that don't require it. So I set it at the domain level, really only needed it for this group of servers, this RDP server farm, and really they've accidentally set it for everything, and now people can abuse RDP. So that's 2012. Major, in my opinion, major move forward. Minor challenges, but it's important to understand why people might flip these bits, particularly in the sections we're about to get to. All right, next slide, please. So we like looking at our data and trying to understand ways to make it serve our customers better and to understand it better and to bubble up things that they might be concerned about. And whenever we scan an asset or scan a service, we try to collect all the data we can possibly collect, like try to squeeze every bit of value out of it, particularly if it's security related or operationally related. We want to get as much value out as possible. And for RDP, one of the things we do is we try to enumerate all the various authentication mechanisms. And in this case, we do it because Rob wrote it. We authenticate all the authentication mechanisms, and we try to share that as attributes on the service, so you can go see and audit and query to find those, to be able to ask yourself, what systems do I have that support RDP and SSL authentication? Maybe I need to go fix those. And so I wanted to cover some of those attributes, just sort of explain what they are and what values you expect to see. So the first one is RDP auth NLA. It basically just says, does this target support NLA? Not does it require it, but does it support it? You want to see supports all the time. Like, you want to see the value of supported in that field every time. RDP auth or RDP, it indicates whether or not the target supports legacy RDP authentication. That's that RC4 broken mess that I talked about early on. If you see it, it's a red flag, it's bad. Like, you should not, in a modern environment, this should be never seen or incredibly rarely seen and well understood when it's there. And then RDP auth SSL indicates whether or not the target allows you to use SSL to protect your comms. It's not as good as NLA, but it's still worlds better than the RDP auth. And any of the bottom two, the RDP auth and SSL, if you see a value not of supported, but of error hybrid required by server, that means that these are disabled and you have to use NLA. That's what you want to see for these values. You want to see the server say NLA is supported, and these other two authentication mechanisms tell you to go away, that you need to be using NLA, that error hybrid required. That's the desired outcome. So we have this data in our environment, and what we wanted to do is say, okay, we know that by default, starting with Windows 2012, RDP NLA is required. In the real world, are people leaving it that way? Are they flipping it? Like, does setting that to required by default have a meaningful impact on the environment and the security outcomes and the postures? Like, are people flipping it back? And we believe we can answer that. So next slide, please. Oh, before I go to the graphs, this is what the RDP attributes look like in product. And this is from, I think, a 2016 server where NLA is enabled and RDP and SSL authentication are not. They tell you to do NLA. The bottom two are special case authentication. They're like, in one case, it's NLA plus, and another case, it's a variant on TLS. It's pretty much fine to have those both supported. What you really care about is are RDP and SSL authentication supported. It is slightly confusing with the SSL and the TLS, but the two things you care about is RDP and SSL themselves. Next slide, please. So this is where we get down to, do secure defaults matter? So what this visual is a breakdown of the percentage of Windows operating systems that we saw in our data set by percentage. So you can see like Windows Server 2019 is roughly 42%. And then each individual bar is broken into two sections. The teal section on the left is NLA required, and the yellow section on the right is not required. And what you want to see, ideally, is as little yellow as possible, because you want all your hosts requiring NLA. And to sort of tell the story here, I'm going to start from the bottom. Windows Server 2003 R2, that's pretty much all yellow. 2003, 2012, and 2008. They're all pretty much all yellow with little slivers of teal. It's kind of hard to see what it is because you're seeing this is sort of a 3D graph. So you're seeing the edge of the yellow. So it makes the yellow look larger than it actually is. But for the most part, none of them, for the most part, they don't require NLA that often. It's sort of rare. And that's to be expected. They either didn't support it in the case of 2003, or it wasn't the default. Like folks are just going to leave the default alone. Like I said, lazy admins like me. And then as you move forward into the future, 2008 R2, you see a little bit of teal on the left. It's still mostly yellow, but a little bit of teal. And that's the people who have intentionally configured their systems to be more secure. Because if you only support NLA, that means you turned off the other stuff. That's great. These people are paying attention. They either have auditors or some other reason why they're configuring things to be more secure. And then as you move forward sort of chronologically, and we'll skip up a couple levels to 2012 R2, what you see is roughly 50%. So this is a version of Windows where NLA is required by default. And 50% of the folks have left it in place. Now, 50% of the people have disabled it, have untoggled that and allow older versions. And I look at that and I think it's probably due to compatibility reasons. Windows 2012 R2 wouldn't surprise me to be an environment with very old systems. And so at least 50% of those, though, have left that the way it was. They've been able to survive with a more secure version of RDP authentication. When you look up to 2016 above it, it's now at 70–75%. So that's great. That means more people, more assets are being left in this default condition that is more secure. It's a better outcome. And as you go to 2019, the percentage increases a little bit. And then 2022, that's mostly, most of them have NLA required. With a little bit of the legacy protocols enabled. And that can be explained by compatibility. It can be explained by being in environments with group policies that require compatibility, or just left that setting set and all that. But in general, the bulk of these systems are being left in the secure configuration. And the way I interpret that to mean is changing that default to be the secure version of the option and making people actively take actions to use a more secure, to enable a less secure option means it happens less and less, and will continue to happen less and less time because there will be fewer technical reasons for doing that. And so I think this is great. I think this says that setting secure defaults has an actual meaningful impact on the security posture of an environment. And that is particularly meaningful when it's being deployed into organizations that don't have dedicated security staff, that may be exposing assets on the internet and they're not aware of it due to misconfigurations. Like, secure defaults matter more on the edges of things than they do in organizations that have fully staffed security teams and have like rigorous audits and all that. And like I said, some of us are just lazy and we're going to leave it the way the default is unless we have a reason not to. And so secure defaults win in that case every time. Okay. Next slide, please. So we also looked at the data and we're like, hey, some of these don't support NLA at all. What's up with that? And the answer to that is that there's a bunch of Linux systems out there that are using XRDP to provide remote desktop services, and it doesn't, or at least last time I checked, doesn't support NLA. Okay, that makes sense. They don't have Active Directory to integrate with. They're using a compatible protocol, and it's mostly on Linux boxes, so it's not, it's not baked in automatically. So that's great. And the fact that we don't see any Windows systems here, like none show up in a statistically significant manner, is also great. So it's an interesting fact that helps us understand our data, and it's not necessarily a bad thing. I mean, obviously using TLS is better than legacy RDP, but like if your product doesn't support NLA, there's not much you can do about that. But at least these aren't Windows boxes, right? Next slide, please. And sort of, all that being said, and looking into the data, something new popped up, and it's something that we'll probably keep our hands on the pulse of. So GNOME Desktop and KDE Desktop have both recently implemented remote desktop services using the RDP protocol, which I find both interesting and weird. That they would adopt that versus VNC or some other technology. I mean, there's a couple of things in the space that could be used, but they went with RDP, and I think that's kind of interesting. It's in the very latest versions, like if you get KDE's Neon and like some of the pre-release versions of GNOME. So there's not a lot of it out there, but it exists, and there's going to be more and more of it. And the interesting thing about it is it doesn't support any of the legacy stuff. It only supports NLA with TLS wrapping, which I think is great. Like there's a lot of benefits there that we've already talked about. And this is something that we're going to be watching going forward to try to measure how it increases in population wise. Does it replace XRDP? Does it replace XRDP? Do we start seeing more and more populations of that versus, say, Windows hosts with RDP? So it's going to be interesting to watch how that evolves and to sort of keep our hands on the pulse of, do they implement legacy security for some reason, or do they keep within NLA? So that's sort of where we're looking to in the future. And when we have a chance, like once we get a decent sized sample set, and once we have something to talk about there, we'll probably cover it in a runZero hour in the future, or write up a blog post on it. And speaking of blog post, pretty much all the stuff that I've covered here is covered in a blog post that got released today. Thank you, Beth. So if you want to go dig through and read through at your leisure, or you want to look at some screenshots and everything, you can go look at the blog post and reference that later. It also, for our customers, it also contains a couple queries that you can use to find both those systems that only support RDP off, or systems that support RDP off or SSL off. So you can find the queries in the blog post and just copy and paste them into a service search and help you immediately identify those systems that have either of these two authentication mechanisms, which are things you would want to audit and take care of. And I believe that's it.
That was Tom. I've been doing this for decades, and every time you talk about something, I learn something new. It always it amazes me. So thank you for that. And yeah, it's fascinating. Please do check out that blog post, because you can use runZero to figure out this situation on your network and say, okay, well, I want to see this query go down to 0. I don't want to see this on my network at all. Maybe you enabled it when you set things up for backwards compatibility reasons, and now you have to say, oh, well, I've upgraded all my clients. That shouldn't be necessary anymore. And you can use these queries as a source of auditable truth, I think would be the term. So, but thank you so much, Tom. That was super, super interesting. Moving on now. So Blaine is going to tell us about challenges in OT protocol implementation. And Blaine, I've read that low-level network programming is actually super easy and there's no problem with it whatsoever. So have I been misled?
Yeah, everybody can do it. You just need a computer. So thanks for that. I've been digging into a lot of the OT protocols for the past months here, and finding some interesting new ones, as well as like ones way back from the 90s or before that. So we'll cover those in a minute. So yeah, like I said, most of the OT protocols are like very, very, very vendor specific, because they not only produce the hardware used in either manufacturing floors or remote sensor locations, but because they understand the hardware so well, they implement their own network protocols to be able to communicate with those. And so given and in these spaces on these really, really small microcontrollers or embedded systems, compute and memory is a very rare and scarce source, resource. So they sort of make concessions on the protocols that say want to super bare bones, like, so sometimes not a lot of security goes into these. They just need to get the data from A to B and back in a very reliable, which is more important than secure manner. And so, it's trying to dig through some of these protocols, like the documentation is either like really old and accurate, some like scanned PDF from 20 years ago, trying to reverse engineer that. Or they're in a different language, could be in Japanese or Chinese or something along that nature, because the manufacturer is from overseas. Or they're just like, it hasn't been used for so long that it's just completely out of date, and nobody really uses them anymore or implements more stuff on top of these protocols. But some of this stuff is still sitting out there pumping your gas or doing something else, trying to keep the infrastructure you rely on running. And they're all kind of different. Like some companies might take one and tweak it a bit for their own needs and not release the updates for documentation. So it's just a very kind of Wild West kind of situation sometimes, which is a part of the interesting piece about all of this. But you can skip to the next one. Yeah, so again, like part of these like packets themselves, they could be either very, very, very simple to get this information back and forth, or they can get super complex, like this particular packet structure right here, which I think you call, was it DMP3? This is
that's DMP3
you pulled off from?
Which is it's a super neat protocol, but there's a lot going on. It's very elegant in its design and what it needed to do. There's multiple layers of validation, because it was designed to run on noisy networks and noisy links and all that. But yes, very very complicated, beautiful complexity is what I would say.
Yeah, and all of this stuff is sort of sitting on the traditional like IP based stack too, right? So you have all of the checksumming of Ethernet, then you have the IP checksumming and the TCP, but then sitting on top of that, they sort of repacketized and rechecksummed and reconfigured and reassembled all of that on top of it, which is why this particular one is a rather complex one as opposed to some of the other much older ones. Vendor thought that was important, but DMP3 being one of the more popular ones that is sort of sifting around the internet at this case. But cool. Yeah, and again, like these, it's like they have like these like special submodels and different different hardware devices of different versions. Sometimes there's not even like tooling that comes along with these things, where it's just like literally just PDF sort of sitting out there that like you need to pull stuff from. And it's hard to even like get your hands on some of these actual hardware devices, because even simulators out there and resource tools are just not available because everything is so rare. There's a few sources of like honeypots and stuff that you can sort of find and use to give you some sort of confidence that what you're working with is going to give you the results that you want. But all of the actual hardware being either like a paid service behind a paywall, or you have to go spend thousands of dollars to buy these devices, and the vendor might sell thousands of different devices depending on the use cases. And so just trying to come up with a relatively, straightforward like implementation of like, how do I identify this stuff without needing to, go break the bank to buy all of these devices is one of the major challenges that we're sort of facing here and there.
And so with that, there's one of these protocols that is, we're going to talk about two of these, right? We're going to talk about PC-WORX and ATG. And every time I see ATG, I think Advanced Technology Group, which was the group at Apple that gave us HyperCard. And I'm still sad about HyperCard, but this is not HyperCard. This is something else, right?
Correct. Yes. And this is actually a really good screenshot to represent that. So this particular one, the automatic tank gauge, was used specifically to monitor the oil and gas levels in these tanking systems, sort of like that are all around the country at this point. It is not a protocol used to actually administer and pump gas and move the fluids from tank to tank. It's used strictly to gauge the current levels in the system, to figure out what the level is, the density, the volume, and especially from the especially for leak detection, which I think it was around the 90s was where the EPA sort of like instituted a guideline or a requirement that all of these gauging systems employed a way to measure at so I think it was a 0.2 leak rate. Like, we need to know when these tanks, if they leak, what that rate is from a federal level. And so this is what this protocol is supposed to be dealing with. And I'm pretty sure the last time I looked at the PDF was a couple days ago. It has over 100 different commands that you can send the leveling systems on these gauges over the wire to figure out like what the tank levels are, run system tests, identify what kind of software levels they are, when they were last patched, to sort of all of this stuff to just probe and figure out what software and what the levels are on these tank gauging systems are. So it's super complicated, like long list of stuff, but the output is pretty basic. It's like that last screenshot that you showed, like that's kind of the output. It's ASCII text in weird tabbed format. Like, as long as you got to parse this, not exactly, not the easiest computer friendly one. There's two different versions of it for like display and machine, but yeah, most of the time you see cases like this. Well,
and so what is this, a secure protocol, ATG?
Well, I mean, it does run on IP and TCP, so you get sort of some of the benefits on like the traditional security models of network segmentation, whether you're doing firewalls or VLANs. But now spreading that over, the vast plains of Texas or even like the Midwest, like all of this stuff is sitting out there. Like, it's a fair challenge to sort of network segment all of this stuff in the remote areas when you just don't have physical access to it sometimes. But the protocol does actually give you a security code that you can just embed in the actual ATG data packet at the L7 level, but it's optional. That is a shared secret. So you can, shared secrets always have their limitations on actual security, whether you want to brute force it or you can keep trying, different combinations of things like that. And it's not the longest secret either. I believe it's only like 8 bytes or so. It's not a super complicated, super long thing. So, it is susceptible to sort of brute forcing and getting through it. And again, because of where it's used and why it's used, like it's all over the place. And some of this stuff, especially since it came out in the 90s, chances are a lot of stuff is very, very old.
Hey, I came out in the 80s. What are you saying? So
yeah, so did I. We're we can't probe you with protocols to find out information. And again, on the remoteness, like you got to put them on the internet. Like, if you want to be able to probe them for remote places, you got to give them a public IP. You got to do all this stuff. So that stuff's out there. But like I said, I would like to still stress that like this protocol is strictly used to get the tank level stuff. So it's not like an attacker could potentially like start slamming this thing and get information out of it, like the software version, things like that, on like how it's actually mechanically pumping gas, or whether you can like trigger to overfill or underfill or anything like that. So this is strictly domained into leveling and sort of system status sort of information. So while not super critical bad if it leaks information, but still
it's out there.
Still information nonetheless.
And what about PC-WORX? What is going on there?
So on the other side of the equation, where ATG was decades old, PC-WORX is more of a sort of a comprehensive suite of software practices, guidelines, and hardware coming from Phoenix Contact to deploy sort of whole area sort of infrastructure OT deployments. So along with buying these devices on the right that you see pictured here, you actually get like software packages, sort of like Word and Excel and all that stuff. There's a whole software suite that goes along with being able to program these. And PC-WORX itself is the actual programming environment to send out your ladder logic or your block diagram programming programs out to these specific devices, but that the PC-WORX sort of suite of software is the one that facilitates that. So you get a lot more sort of like control, and like it's way more up to date. You get patches that are sort of regularly coming out. But again, like the actual protocol for PC-WORX itself is the programming of these things. So you can talk to it over PC-WORX protocol, sort of based on Ethernet and IP. You can do the same things for VLANs and firewalls, all that stuff you get for free. There is some mechanisms for sort of encryption and decryption on the on the PC-WORX side, but again,
a little bit higher
way
security.
Way more higher security and well more documented to pull apart. So
awesome.
Cool.
Yeah, those are always fun, those protocols. Thank you, Blaine. And so I wanted to take a quick digression into the SECA Clean Energy Cybersecurity Accelerator Cohort 2 runZero public report. And we actually had a webcast last month where we invited some of the SECA folks to talk about the challenges of securing OT and ICS environments. And runZero participated in Cohort 2 of this accelerator program, where it talks about the concerns of OT and IT convergence and how this very geographically dispersed devices from multiple vendors, and as Blaine was saying, some of them decades old, where they're all there, and how it is often these devices are not designed to handle unusual traffic or large amounts of traffic or things like that, to the point that active scanning was often considered taboo or verboten in these environments, and with good reason, right? Like this wasn't, this concern didn't come out of nowhere. But what this report did was it tested runZero on a variety of scenarios with initial discovery using active discovery, change discovery, and then passive discovery with runZero's traffic sampling, and then discovery of assets at scale. And it was really fascinating in that this report goes in depth with a smaller scale generation lab, for example. So this is supposed to look kind of like an electrical distribution network with a substation and power generation and things like that, and how we could discover assets in this environment. And then also a simulated much wider environment that simulated a much larger and more distributed and more interconnected environment, and discovering assets in that environment. And what was fascinating is that, and I love this quote, using solutions such as those offered by runZero to identify control system assets and to monitor changes in that equipment is expected to improve the security of the industry as a whole. Active scanning had no adverse effects on ICS assets or ongoing SCADA. So that was really fascinating in that it really pleased me to hear that we were able to maybe show that active scanning isn't as scary when it's done properly, when it's done correctly. It isn't necessarily as scary as it might have otherwise been. So I highly encourage you to read that report. That's linked there on this page. And there's also the webcast that we had the SECA folks on last month that I would highly recommend that you watch because it was super fascinating. And with that, I'd like to hand the virtual mic over to Tyler, who's going to talk about pushing product parameters, say that 5 times fast, with the API. So Tyler.
Thanks, Rob. Yeah, so taking a little break from your protocol digest here to talk a little bit about what people are doing. Probably some of you attending are customers. It's probably interesting to see how other people are using the product. So specifically, we're going to talk a bit about the API today. So just to kick things off, what are the different ways that people are using runZero? So there's kind of 3 main user profiles. The first one is your day-to-day user. A lot of the times, these people are just using runZero to run searches during investigations, maybe using some reporting as needed, and then updating asset information like ownership as needed. So primarily just using runZero for the data that's there, not trying to do anything else with it, just like looking at it using the UI. Your administrators, so these are they'll have a lot of the day-to-day type profiling, but then they're also managing runZero for their company. So configuring the scan tasks, setting up integrations, and using more advanced functionality like alerts, goals, like kind of getting things primed for these day-to-day users. And then these power users, these are people that are going above and beyond things that runZero supports out of the box as features. And they're integrating runZero in ways that isn't necessarily available just through feature functionality to integrate with their workflows like SIM, SOAR, things like that. So you have some percentages there. So just to kind of like get an idea of how these percentages end up happening. So a lot of your large enterprises have a ton of these day-to-day users. Like we have some customers with like 100 users in runZero, so that's where you see a lot of these. That makes up like the 60% there. And then the admins can be any size customer. Sometimes you have people accounts where it's just like a few people that are on the security team and they're kind of doing everything. And then on the larger accounts, you have these as well. And then the power users, they can come from anywhere. Sometimes you have like a 2-person security team, but like they're just doing tons of stuff with the API, you know. So API usage is then most commonly for these power users. And then you can go to the next slide to see. So a few different ways people are using the API. So creating custom integrations, this is probably like the #1 thing. So we have a little code snippet here. And I think Beth is going to share the full script here to see a sample custom integration. We have a customer that has their task creation fully automated through a Python script, which is cool. And it sounds like a lot of work went into that one. Integrating with existing tooling. So a lot of this is just exporting data, refactoring it, doing whatever they need to do, and then like either creating a report, putting it in some other workflow like a SOAR or something like that. And then from there, you kind of can think of the million different ways people might be doing that.
Yep.
So you can go ahead and move it to the next one, Rob. And then, so how does runZero like use this to improve our product? Like the way we look at it. So if I'm working with a customer as a customer success engineer, I see someone putting in this much effort to like write custom scripting to fit things into their workflows. That means it's probably pretty important to them, right? So, and a lot of our other customers that maybe aren't going to be able to put in that effort, whether it be due to lack of cycles and time or just the skill set being there, they could probably benefit from a lot of this too. So one example of this is we had a very large customer doing tens or maybe more acquisitions a year, so over 10 at least. They had an M&A requirement to create like a risk report. So they would throw an Explorer in the new environment, run a runZero scan, and then they needed a way to understand the risk as a whole. So there was a day in runZero where you see this screenshot on the right where the query library did not show you how many matches you had when through the list there. So you just had a list and you had to literally click everyone to see how many matches you had. So they created a script that ran every search and created a report through CSV. And this was one of the things that kind of this idea sort of drove us to create this functionality. So now any user can run a scan and see exactly how many matches they have with anything in the query library. So hopefully now you have a good idea of like how some other people are using the API and how that does lead to us innovating in the product as well.
Yep, I love it. I love our API. I really do. And we've got a Python module that you can use. It's super great. So thank you very much, Tyler. Thank you for joining us. Now let's move on to the rapid response roundup. And this is but a small section of the number of rapid responses that happened this month. But I do want to highlight a couple. You can see that we just picked sort of the most severe ones, except for this one at the top here, the Avanti Cloud Services Appliance, which has a CVSS score of only 7.2. So why is that interesting? Well, it's interesting because there is evidence of in the wild exploitation, which is interesting because it's an authenticated privilege escalation vulnerability. So you already have to have access to the system, but the vendor has disclosed that there is some limited evidence of in the wild exploitation. So Definitely check out the rapid response blog post on that. We have queries to help you find the relevant systems. And also the vendor pointed out that this product is past its end of life date. And so this will be the last patch. They recommend you update to 5.0 for that one. There was also this interesting one with the CVSS of 9.8. What happened here was a vulnerability in the Microsoft Windows 10 servicing stack. And what was fascinating about this was it wasn't a new vulnerability. It was actually an issue that caused some of the previous fixes to be rolled back. So existing vulnerabilities were re-exposed. And there's not a huge amount of detail out there just yet, but this implies that existing threat intelligence is suddenly reapplicable. So that was, I thought, interesting, that it wasn't a new vulnerability, but it was the resurfacing of some older ones. And then also with Siemens. So Siemens is an OT ICS industrial equipment manufacturer, and they have a ton of devices. I mean, thousands and thousands of minor little variations. And so they released something like 30 advisories this month for different systems, not all for one system, obviously. And some of those systems are EOL or won't be patched or haven't been patched yet. So even if you are keeping up to date with this sort of thing, it just sort of goes to highlight why defense in depth of OT is so important, because you might not be getting a patch as quickly as you would otherwise like. So definitely check out the runZero rapid responses. These are a really good way to keep up to date with the security landscape, the threat landscape, and see if your systems are affected by these issues. And then so finally, I want to talk just a little bit about some new features in the EOL tracking in runZero. So EOL stands for end of life. And this is where the systems are no longer supported by vendors, just like we were talking about with Siemens just recently, or with Ivanti prior to that. So runZero has recently come out with some dramatic improvements in how we are tracking EOL coverage for different operating systems. So you can actually go in and we will try to match the operating system that we detect with a end-of-life database, and allow you to query for assets that have exceeded their end-of-life date, their best by date. So that's, I think, a really we've supported EOL for a while, but this was a dramatic improvement, and I really hope that it gets some use, because I'd like everybody to know about their assets that are past its end of life. And so with that, we have brought yet another runZero hour to a close. I want to thank you all for joining us. It was a really fascinating time. I want to thank all of our panelists. I learned a lot. I hope you did too. Next month, we have a very special guest. Tyler, you're a very special guest too, but one of my favorite people in the world will be joining us. So I want you should definitely check it out. It's going to be a lot of fun. So thank you, everybody, and have a good rest of your day.